Hi, and thank you for attending this Alconox presentation. I'm going to talk about what's clean and why. So first, today's talk, we're going to talk a little bit about, introduction area. We're going to talk about critical cleaning. We're going to talk about a little bit of chemistry, just enough so you can spell the word. A little bit of cleaning methods, how to select some of them detergents, a little bit about the process. And one of the things that we really want to talk about also is why our Solujet is so much better in your CIP systems. So first, to start off with, part of the introduction, who's this guy talking to you right now? I've been in the industry for over 20 years. At 20 years, you kind of want to stop and just put a little plus next to that 20 because that's kind of good enough. And that means pharmaceutical industry, medical device industry, laboratories, troubleshooting, critical cleaning, analytical chemistry. I stayed at a Holiday Inn Express, so I can do a lot of different things. So Alconox has been around for over 75 years, going back to the 1940s. And what we do really well is making detergents that are free rinsing. They are interference, residue-free. They're aqueous detergents. That means because we're cleaning in the pharmaceutical industry, the laboratory, and medical device industry, that means no dyes, that means no fragrances, brighteners, softeners, nothing like that, nothing that will leave residues on your valuable equipment. So, as I quickly mentioned about Alconox, we're since the 1940s, third generation, family owned, still the same two families. And again, our big areas, pharma, med dev, laboratory, precision manufacturing. We distribute in over 65 countries, all 7 continents, yes, even Antarctica, and all 50 states, of course. So one of the things I like to do is get everyone on the same footing. So what is critical cleaning? What are you really talking about? Well, critical cleaning is wherever you can impact the final product. So if you have a process that cleaning can absolutely affect the quality of that finished product, you're doing critical cleaning. Typically, you want to have some kind of observation, validation, verification measurements that are quantitative that you can use to measure this. And critical cleaning, especially when you're talking about FDA or USDA regulated industries, and this part is very important, so please listen. So where you have components or substrates is the complete removal of undesirable contaminants down to a desired preset level. Very, very important point. That's why I say it like, your old second grade teacher did. The present level is normally the minimum level at which no adverse effects take place in a subsequent operation. Another very important point. Now, why are we talking about all this stuff and why are you bothering to listen to this? Well, I love to give the horror story. This is the thing that both, people working in a lab, working in manufacturing, and especially the C-suite need to pay attention to. So over 20 years ago, there was a company, and this one happened to be a medical device company, but they took a process that they used to do inside, and they had it out, and they said, you know what, let's bring it back in-house. It's like, excuse me, and said, yeah, that sounds like a good idea. They did not revalidate that process. So they cleaned and they passivated these products, sent them out, and then had failures in the field. Now, when you do an implant, so these are class 3 medical devices, when you do an implant, last thing you ever want to hear is someone having to do an explant. Implant go in, explant go out. So there were 17,000 explants. Class action lawsuit because of this problem, over $1 billion. This company was broken up and doesn't exist anymore. So that's my scary story to why critical cleaning is critical. So talking about some of the chemistry. So you can, in terms of cleaning, you can have organic solvents, you can have water, you can have commodity chemicals, anything like that. Detergents, you name it. So other types of things that you can have, like we were mentioning the organic solvents, there's things like alcohols, ethers, petrochemical, here you can also have the problems of volatile organic carbons, flammability, and waste disposal. Water is excellent when that's all that it takes to clean, but the thing to recall, or the thing to understand, is that most things, especially in the pharmaceutical industry, are often not water soluble or have problems with water solubility. That's when you're going to need other types of agents. And there you have your commodity chemistries, things similar to, or things like sodium hydroxide, potassium hydroxide, phosphoric acid. But these all have single cleaning mechanisms. We need more. Detergents are synergistic. They have a combination of actions in order to do the cleaning. So here you get to have a lower concentration of chemistry, you have safer formulations, easier waste disposal, and a broader range of residues can be removed because you have a multitude of actions. You have lifting, you have wetting, you have emulsification, sequestration, a multiple of mechanisms. And again, as we mentioned, when you have critical cleaning, especially in FDA-regulated industries, no dyes, no fragrances, and you don't want to have anything like rust inhibitors left on your equipment. Always remember that. This is kind of a cool slide that I like. It kind of shows in a two-dimensional way kind of what the actual detergents look like, and as they pull things off of a off of a surface. So here you have things like surfactants pulling oil off of a surface. So it's kind of neat. If you can get a copy of the slides, I highly recommend looking at this particular slide. So let's talk quickly about the water. Water has things like hardness. And what do I mean by that? It can have magnesium, calcium, manganese, iron, these type of things. And these type of things can do fouling, and they can wind up causing like soap scum and those type of issues. That's where having a purified water often really helps. This would be like deionization, ultrafiltration, FO, things like that. So what are the different types of cleaning methods? You can have manual cleaning. This is basically buckets and brushes. You can have things like soaking, agitation, or the CIP systems, which are a spray in air type of cleaning. So as I said, manual cleaning, here you have to be kind of careful about the workers, and you want to make sure that you don't have something that's very alkaline or very acidic, or otherwise, you want to be careful of safety issues besides just being efficacious. And the other thing is that this can be really labor intensive. Now, manual cleaning also requires tools, so you can have things like nylon brushes. There you have to make sure that they're stable, that they don't degrade upon contact with any of your detergent. So this is very important to make sure that your brushes don't wind up getting into your manufacturing equipment. So another issue is soaking. This is something where, let's say that you have something that's very, very difficult to clean, and what you wind up doing is you wind up soaking in your detergent solution. This can often take a while, but it can loosen up very difficult residues. Spray and air, this is the type of thing where you can have dishwashers or the CIP cleaning systems. These have the advantages of a little more consistency, and you can have it automated far better. So typically in the pharmaceutical industry, you'll have your clean in place systems. These will be like your recirculated cleaning and rinsing solutions that are used. And you can have either static spray balls or dynamic spray balls. Static ones are still, and of course the dynamic ones move around. And here you want to make sure that you do good riboflavin studies to make sure that you have good coverage all over the surface. Often the CIP systems can be in place so that they are engineered in place, or they can be on portable skids. Those are the two most common. So very quickly, how do you choose a detergent? Well, this can be very difficult. There can be thousands of types of cleaners. It can be everything from cleaning your home to cleaning semiconductors. So this is also kind of, next couple slides are kind of interesting to kind of see what kind of detergents are typically good in the pH ranges for what kind of soils. The low pHs are your salts, oxides. These will be things like heavy scales. Your higher pHs will be like your greases, your oils and fats and things like that. And then there are lots of compounds that it doesn't really matter what the pH is, it tends to be more of a neutral. So this slide shows specifically the types of organic compounds that are cleaned in what pH solutions. So again, your oils, fats, greases are better for your alkaline. Your acidic will be things like bicarbonates, metal complexes, metal oxides, hydroxides. There are a number of compounds where the pH really doesn't matter. These can be things like sugars, it can be things like ketones, you can have your heterocyclics. So these type of compounds, it is neutral and really doesn't matter as much. But one thing that does matter also is the substrate type. Typically you'll have like a 304 or 316 stainless steel, manufacturing vessel, but not always. Make sure you check that. Some, if there's any aluminum or things like mild steel, you better check that. And of course, glass typically is going to be a borosilicate glass. Those can have issues in terms of cleaning as well. Other things you want to look for is that will a company give you the regulatory support? Things like, will you get your safety data sheets and technical bulletins and certificates of analysis? Will you be able to get acceptable daily exposures? These are the types of things a company like ours will supply. Here's a general listing of some of our most common detergents, ranking from Alconox all the ways down to our Turgozymes. And we have detergents that are good for manual use, such as your Alconox, and for your CIP systems, like our Solujet and Citrojet. Now, before I get into talking about the detergents used in a CIP system, I just want to briefly hit on your process optimization. There are 9 variables, and often these 9 variables are not covered. So again, I need everyone to wake up and look at these 9 variables. So these are before cleaning, so it's important to know how the equipment is being treated before the cleaning starts. Is this going to sit for an hour or is this going to sit for a week? 2, and that's dirty hold times. Agitation. Is there going to be an impeller that's going to have agitation or is it sitting? Time, heat, orientation, chemistry and concentration. And then after clean, it's your clean hold times, rinsing and drying. And we came up with the acronym BATHO-CARD to remember this. So these 9 variables are very important to think about and optimize so you can have the best throughput and best cleaning process. So a couple of the key points. Every 10 degrees C increase in temperature will typically cut your cleaning time in half. With one caveat, you need to make sure that there are no competing reactions, because if there is, then the increase in temperature could increase the adherence of your residue on the surface. So you can increase chemistry concentration, will increase your capacity and bath life. Other things to consider is increasing agitation. This gives you your mechanical energy. And again, matching the correct chemistry will help your cleaning process and facilitate throughput. And obviously a low foaming detergent will rinse faster than one that has lots of foam. So what are some important points for the bottom line? Well, by having good chemistry and taking into account these issues, you can improve cost with better throughput. If you pay attention to before cleaning, this can speed up the time. Having concentrated detergents makes it more economical. And another is disposal issues. When you have detergents that are biodegradable like all of ours, these types of things are going to help you in your bottom line. And of course, the reliability and quality control detergents are of utmost importance. Last thing I want to quickly talk about here, and then I'll show some references and stuff, is our Solujet versus a competitor. So Solujet is the most commonly used of our detergents in the pharmaceutical industry when you have a CIP system. So it is very similar to the most commonly used. We're number 2 in the industry, last time I checked. And some things to consider is that ours cleans far superior. What do I mean by this? Well, the surface tension of a well-known competitor tends to be around 49 dynes per centimeter. Ours is 33 dynes per centimeter. It has a much better surfactant package. Also, the way that ours is formulated, we try to be below federal effluent standards at a 1% solution, so we try to keep it below 12.5 so that does not become an issue. And then after use, it tends to be closer to 12 or even slightly below after use. So again, highly recommend a Solujet, and for an acid wash, Citrojet as an excellent combination in your CIP cleaning. Just to wrap up, we have some reference and good information to take a look at. Our Aqueous Cleaning Handbook is just going to be updated after 18 years. That new one is coming out in PDF form within the next couple months. We have the Critical Cleaning Guide. That's another excellent guide that gives you basically which detergents to choose, kind of like through a flow chart based on the industry and what you're doing. And of course, we have Tech Notes, an excellent source of answering questions, and our website. We have white papers for which to look at as well. Here are some references, and we have some videos that are kind of interesting on the website I urge you to take a look at. And finally, I just want to thank everyone for your attention, and have a good day.